Even power functions are not one-to-one, but even roots are. So when we take the inverse of an even root, we need to be careful of the domain of the resulting function. So here's how we take care of that when we're taking the inverse of an even root function. So we start with our basic swap x and y move. Square root of y plus 3 all plus 4 equals x. Then we isolate the root. Square root of y plus 3 is x minus 4. And now we consider the domain, right? The square root is always greater than or equal to 0. So we must have x minus 4 greater than or equal to 0. Solving that, we'll have x is greater than or equal to 4. That will be the domain of our inverse function. Our inverse function is going to look like an even power function, so we'll need to note the domain restriction in our final answer. So for the moment, we're going to just put a pin in that, and now we can continue solving, because actually our inverse is given by the square root of y plus 3 equals x minus 4, where x is greater than or equal to 4. In other words, rewriting as a power function, y plus 3 equals x minus 4 squared, where x is greater than or equal to 4. We can finish solving, subtract 3 on both sides, and we've got y equals x minus 4 squared minus 3. Again, restricted to x greater than or equal to 4. And so in function notation, our inverse function, f inverse of x, is x minus 4 squared minus 3 with the domain restriction x greater than or equal to 4. So when we're taking the inverse of an even root function, we're going to end up with a power function that has a domain restriction. Could we multiply out x minus 4 all squared and write f inverse of x as a polynomial function? Yes, we could, but we don't have to. Now, the even power functions are not one-to-one. So we can't take the inverse unless the domain is restricted to make it one-to-one. If we do have a domain restriction, we need to be careful of whether we want the positive or the negative root, so that the range of the inverse matches the domain restriction. Right? We can't have both the positive root and the negative root, but we want the range of the inverse to be the same as the restricted domain of the original function. So let's see that happen in practice. G of x is 2 minus x all to the 4th power minus 7, with the domain restriction x is greater than or equal to 2. So when we swap x and y, we'll have 2 minus y to the 4th power minus 7 equals x. And we'll also have the restriction y is greater than or equal to 2, because we swapped x and y. Now we isolate the 4th power. We'll have 2 minus y all to the 4th, add 7 to both sides. That'll equal x plus 7. And now we're going to think about the range. Right? We have y is greater than or equal to 2. And we want to say 2 minus y does what? It looks like I want to end up with a negative y, so I'm going to multiply both sides by negative 1. On the left, I'll have negative y. On the right, I'll have negative 2. And when I multiply both sides by negative 1, I swap the direction of the inequality. And then I want a 2 here, so I'm going to add 2 to both sides. So I've got positive 2 minus y is less than or equal to positive 2 minus 2 is 0. Okay, so 2 minus y, I want to be negative. So on the left, I'll have 2 minus y equals, I'm going to take the fourth root, x plus 7, and I'm going to take the negative fourth root. Why do I want the negative fourth root? Because I want this to be negative. For this reason. And so I need the right-hand side to also be negative. And now I can finish solving for y. I'll subtract 2 on both sides. And then I'll multiply both sides by negative 1. And that'll give me y equals the positive fourth root again, plus 2. And I don't now need to note the restriction, right? I don't need to note that y has to be greater than or equal to 2. That happens automatically because of the way the radical is defined. My inverse function, I've got g inverse of x is the fourth root, x plus 7, all plus 2. So when I have a power function with a restricted domain, that ends up determining the range of the inverse function. And I need to use that to decide whether or not I want to take the negative root in my inverse function.